Welcome to day 2 of our React journey. So, there has been a minor change in the content of day two's course. I wanted everyone to have a better understanding of React and underlying concepts before we proceed with the application development. So, the content for today's course would be we would understand what is React, what is DOM and virtual DOM, why React is fast, what are components, how we can think in terms of components when we are creating our application. Then we understand the two most important concepts, the useState hook and the useEffect hook, and learn how to use them properly. So, without any further delays, let's get started. First, we come to what is React. For this, let me jump to the React's own website and we can take it from there. So, this is React's website. So, of the key things to notice here are the current version of React, which is 18.3.1. Now, if I have to talk through what is React, so React is a JavaScript library for building user interfaces, particularly single page applications or spas, as you might have heard in your project context. React is very good for developing single page applications where dynamic content changes within the same page. It was developed by Facebook, which now is known as Meta, and has become one of the most popular tools for building web applications. At its core, React allows us, the developers, to build reusable components. It also emphasizes on the fact that we should create user interfaces from components. So, whenever you're thinking of an application, you should think in terms of components, how we can break it down into smaller parts which come together to bring the application to life. You might be thinking, why should I use React? What problem does it solve for me? When you're developing a modern web application, it involves managing a lot of complex logic, particularly when the user interface needs to change dynamically, when the user interacts with a button, when they enter something. So, all these are user actions. In response to user actions, you would want to change some of the things on the page. In plain JavaScript or older libraries like jQuery, it can become messy and error prone when updating different parts of the UI. And at times, it really slowed down your page as well. React solves this by offering a declarative way to define what the UI should look like at any given point in time based on the state of the application. When the state changes, like adding an item to cart, React efficiently figures out what needs to be updated and applies the changes without you having to manually manipulate the document object or DOM. This is something that I will showcase when we are talking about DOM. This was a very high level view of what is React and why we should use React. Now let's move on to the next item, which is what is DOM and virtual DOM. So first, let's talk about what is DOM. So DOM is a programming interface for web documents. It represents the page so that the programs can change the document structure, style, and content dynamically. Extending on this, virtual DOM is a lightweight copy of the real document object model, and it's usually stored in the JavaScript format. To better understand this, let's look at an example. This is a sample HTML code. So you have your HTML tag, which contains a body tag, which has a div with the ID of application, which contains your heading, level 1 of Hello World. This translates into a document object model, which looks something like this. So internally, this is how the entire document object model would be mapped out. And this DOM is a tree of objects corresponding to the structure of HTML documents. So you can see every single element and property that we have added in our DOM or HTML markup is visible in the DOM node or DOM tree that is generated. So if you have multiple sibling nodes, if you added another div or another h1, that would automatically populate and increase the size of your DOM as well. So virtual DOM, as I already talked about, is a lightweight copy of the real document object model, represented as JavaScript objects. React keeps this virtual DOM in memory to minimize the direct DOM manipulation that it needs to do, because direct DOM manipulations are slow. Now, when React renders a component, it creates a virtual DOM tree when a component state or prop changes. React recalculates the virtual DOM and then flips the virtual DOM, which is now the current state, with the previous one. This is called reconciliation algorithm. Only the differences between the current and the previous version of the DOM are applied to the actual DOM. This makes updates much more efficient. So with this visual representation, I think we have a sense of what is DOM, virtual DOM, and how they are interrelated to each other. Now in the next one, we will understand how this makes React fast and how we are using virtual DOM under the hood. For this, we will dive into an component example and see how the updates are made in real time. To showcase this, I have opened a component called diffing. In this component, you can see we have two state variables, count and name. And on click of one of the buttons, increment button, we are calling the increment which is updating the count by the value of 1. So if the count starts with 0, it makes it 1, 2, and so on. And on click of change name button, it calls the callback change name, which will check if the previous value was React, which in this case it will be true. It will update the new value to React.js, or if it is React.js, it will revert back to React. So that way, we will keep on updating this state as well. Let's look at it in practice. The same component that we saw, it's rendered here, and we can see it started with an initial state of React and the count of 0. I will go ahead and click on increment and keep a close eye. Let me zoom it a little and keep a close eye on the increment, the h2 which contains the count. When I click on increment, only the h2 containing the count is updated and changed, not the entire component. And same happens when I change the name. Now h2 will not change and only the h1 containing the name will be changed here. And this is diffing algorithm in action. What React did under the hood is it created a virtual DOM which created this structure of the components that we see on page. And whenever I'm updating something, it takes a snapshot of the new next set of changes and compares it with the previous state. And it identifies now it's the h2 that needs to change because only the count has been updated. And it propagates those changes to our document object model and updates them in real time. That way, the changes to the document object are very minimal and this makes it really, really fast. So with that example, I hope it was clear why React is fast and how it uses a lot of additional logic under the hood to ensure that the update to DOM are minimal and updated in real time. Now we will try to understand what are components and how we can align our thinking to think in terms of React and components. For this, the best place to start is the React documentation itself. Let me open up the documentation. So what are components? Components are the building blocks of any React application. They allow developers to break down complex user interfaces into small, reusable, and self-contained pieces that can be managed independently. Each component is responsible for rendering a specific part of the UI or user interface as we call it, based on the data and its own internal state. To understand this a little better, let's go to the Learn section of the react.dev. In terms of describing the UI, your UI as a tree. I find this section really helpful in trying to understand how we should think about our component breakdown and reusability. Here we can see that the outcome of our application is a card that shows us an application section which gives you a number of inspirational quotes that you can put in your application and it presents them in a very aesthetically pleasing way. If you had to create this application, even though we can put everything in a single HTML and JS, it will not be as reusable as we want it to be. So in terms of React thinking, how we are restructuring this is we have an app component that creates this entire user experience. How it creates that experience is by rendering two different components, an inspiration generator and a fancy text, as we can see here as well. Fancy text is rendered on top with the text get inspired app and an inspiration generator which takes in copyright as a child component and then renders it on screen. This probably is the copyright. Now, another key thing to take note of is fancy text is being reused. So there's a component called fancy text which is showing me get inspired apps and I'm assuming it also showcases this quote because this is also a fancy way of showing a quote. Let's take a note of the component first. So here we can see fancy text. We are passing the text along with a property called title. That means title is set to true in this particular case. In fancy text, we can see if title is set to true, we return an h1 tag with fancy title class names and the text that we sent out. If title is not passed, it will give you an h3 with a class name of fancy and cursive with the text that you're passing to the component. So in inspiration generator, even though we are using fancy text, we are not setting title to true. If we add title here, you can see that fancy text works in a predictable way. Title is set to true. You see both of those tags get updated to h1 with the same styling. But in here, our need is to show the code which is working correctly. In here, we can see we have this button. On click of this, we update the index. We have a list of quotes which has 3 quotes. And on every click, we are updating the index by 1 and then calculating the remainder using this modulus operator so that it never goes beyond 2. So it will always give you values 0, 1, 2, 0, 1, 2. And that's why it keeps on cycling between the 3 quotes which are available. This is how we should think when we are creating a new application, how we can break it down into smaller reusable components which give us the experience that we need. Another important thing to understand is this markup that we see is called JSX, JavaScript XML. This combines HTML with JavaScript. So it puts your markup into JavaScript, and roughly this is how the consolidated JSX markup looks like. So you can use certain JavaScript properties, conditional rendering to create HTML markups as an output. There are certain callouts whenever you're converting HTML to JSX. For example, if you directly paste this inside your component, it will not work. You see, it breaks and gives you an error. That's because there are some considerations in JSX which are we always need to ensure that a single element is returned from our component. In this, we can see that there are 3 nodes at the same level and there is no parent node associated with them. What we need to do is we need to wrap them in a div, or if you do not want to wrap them in a div, you can wrap them in a fragment. This is called a React fragment. Whenever the component renders, only the content of the fragment is shown on the document and there is no wrapping HTML markup that comes up. That way you reduce the burden on your DOM tree as well. Second thing which we need to ensure is we need to close all the tags. Image tag, UL tag in HTML. So the tags are self-closing, but in this case, we need to explicitly mark them as closed. So image tag needs to be closed, your lists and everything needs to be closed appropriately. You need to camel case most of the things, not all. You can see they're cleverly calling out that we don't have to camel case all of the things, and the reason for that is below. Class is a reserved keyword, that's why we use class name here and we camel case it. And most of the properties on click, on mouse enter, on mouse up. So if you have a prop called stroke width, it will be renamed as stroke width here. So that's why we camel case everything. But some of the things which we don't camel case for are ARIA attributes and data attributes. For people who are familiar with accessibility, they would be aware of ARIA attributes. It is used very frequently to create accessible experiences, something that we'll dive later in our journey of React. So yes, ARIA attributes and data attributes are something that are written as in HTML with dashes. Now, this gives us a complete holistic understanding of what are components, how we use JSX to write our components, and how we should be thinking in terms of our component structure, break down our UI in different components, create the experience that we need. Next, we come to understanding useState. In React, useState is one of the most fundamental hooks for managing state in functional components. Understanding the difference between useState and regular JavaScript variable, as well as the concept of a component state, is crucial for building interactive UIs. So first, we need to understand what is a component state. The state of a component refers to the data that influences the component's rendering and behavior. Unlike some of the callbacks or props which are passed into a component from a parent, state is local to the component. State is usually mutable. That means it can change over time, either through user interactions or through some asynchronous calls. Some of the key characteristics of state are it is local to the component, it's private, and fully managed within the component. It cannot be accessed or modified by other components directly. Second, It triggers re-renders. Whenever the state of a component changes, React re-renders the component so the UI reflects the latest state. And third, as we already mentioned, it's dynamic. It's mutable, which means it can be changed due to user input, server responses, and any other events. Now, what is useState? useState is a React hook that lets you add state to functional components. State in a React component refers to data that can change over time, typically due to user interaction or other factors like server responses, as we discussed. This state determines how a component renders and behaves. When we call useState, we are essentially telling React, hey, I want to maintain this particular piece of information over time, and if it changes, please re-render the component with the new information. To see this in action, we will look at a code example now. Here on screen, as we can see, we have a component called state counter. This is a stateful component, which means it has a state variable, a setter for that state variable, or a function that updates the state, and the initial value of the state variable. Whenever you use useState, you get a state variable, its setter, and you need to pass the initial value of your state variable. Now, for this component, count is the state variable that keeps track of the current count. setCount is the function that is used to update the state. One thing to keep in mind here is, and a key callout, that even though we can see that we have the method called as setCount, React does not enforce us to name it same as the state variable that we're using. For example, I can rename it to set new value and it would still work. The code, if we have a look at the code, whenever I will increment, it will continue to work. It does not throw any error. It's not a good practice. Why? Because in a component where you have to manage a lot of states, it could become confusing if you're not using the same name. When are we updating which particular state variable? So that's why it's an established best practice to ensure that we call the setters with the same name as that of the state variable. So if you have a count as a state variable, setCount becomes the setter. Now, whenever the button is clicked, we have a handler that is called. And what that handler is doing is it's incrementing the count by 1. Whenever the count is updated by 1, React re-renders the component and the updated count is displayed on the screen, as we can see here. I will go ahead and click on increment now, and just to show the updates, I will open the div. On every update, the count is increased by 1, and we can see that reflected on the screen immediately. Now, one of the common questions that we keep on getting is, why should I use useState when I could just use a regular const variable? Or how is useState different than a const variable? So the key difference is how React reacts to changes. The regular const or let variables are static once assigned in a render. The values will not persist across renders or trigger re-renders of the component. When a functional component is re-rendered, all the local variables are re-initialized, which means any updates to a regular variable inside a component are lost after the next render. This is something we can see right now in the next set of code example. So here, in this example, look at the component that's on the right side. It is called a non-state counter. In this component, we have the regular variable called counter, and the structure of the component is same as that of the previous one. We have a variable that we will use to track the updates. We have a handler to handle the click events, and in the click event, we are updating the count, the same thing. And what I'm doing additionally is I'm logging the counter variable so that we can actually infer that handle click is getting called, because you will not see the count get updated on the screen for this component. Because every time the component will re-render, it will set the counter to 0. And even though handle click increments the value, the UI will never reflect the updated counter because React doesn't know it needs to re-render the component. Let's look at the working example now. Here, on top, we have the state counter, and below, I have a non-state counter. Let me refresh the page. So it gets reset to 0, both of them. We already know that the component on top is a stateful component. And that's why whenever I will click on increment, it will increment the value. Now on non-state counter component, I'm clicking on increment, but nothing gets reflected on the screen. But if I go to console, we can see on every click of increment, I'm getting a new value onto the screen. So why is this happening? It's happening because the value is not a stateful value and React does not react to its updates. And this is because React doesn't know that it needs to re-render the component. Now I will close this non-state counter and we will discuss one of the use cases which you might not see regularly in your regular projects, but when it happens, it causes some issues which are hard to debug. Now, for example, the requirement is I want to increase my count by 2 every time I click on handle click. So, okay, one of the developer goes in and changes this to that I'll call this set count 2 times. And ideally, from the looks of it, it should update the count by 2. You're calling set count with +1 and again set count with +1. So the output should be 2. And let me add a console log so it's very clear that this is getting called and updated. Console.log value should be updated by 2. And here we have it. Save. I'll click on increment. You see, I'm getting the log every time that the value should be updated by 2, but the value only gets incremented by 1. Weird. Let's go back and try to add it a few more times. I'll duplicate it 2 more times. So ideally, now the value should be updated by 4. Go back to our example. And now on click of this, still the value gets updated by 1. I see the log that value should be updated by 4. And in source as well, you can see that the code actually reflects the value that we have updated. But for some reason, it's not incrementing. And this is a very important concept to understand. Why this is happening is because React's state updates are asynchronous and are often batched together to optimize performance. When we call set count twice or thrice or any number of times in a row, React doesn't immediately update the count value. Instead, it queues both the updates and performs them. So essentially what is happening is whenever we call this set count, React dispatches an asynchronous update and tries to batch it with other state updates that are going on. So it encounters the first state count, sees, okay, count is right now 0 and I need to increase it by 1. Then it encounters another set count and here also checks, okay, count has to be increased by 1. So far, it has not increased the value of count. So essentially, the value of count is still 0 in all of these cases. And when all of these 4 state updates are batched together, you see the count getting incremented by 1. So essentially, this is the code that is running. How do we fix this issue? It's an issue which when you encounter, you want to fix it right away. To solve this problem, we can use the callback version of set state or the setters, whichever you get out of your use state. This will give you access to the previous state. What I mean by that is, let me undo these and I will now use prev count. And whatever is previous count, increment that by 1. And I will replace this with every single instance. So here, here, and here. Now we see in all of these 4 cases, we are using a callback version of set state. This should give us access to previous count. And now what this will do for us is React will provide the most up-to-date value of count for each of the state updates. So first set count will increase the previous count from 0 to 1. And then the second function call that we are getting will get the latest value of 1 and then increment it by 1 and so on. Let's see that in our example now. I'll refresh the page. I'll click on increment now. And here we can see the current count gets updated by 4 on each of the clicks. So this is one of the trickier things that you might see with your use state implementation, but just a call out to ensure that you don't miss out on this if you're facing this in your application. So you might be questioning, why is React doing this? So React does these batch updates for performance because performance is the most important thing when you're dealing with DOM updates. If React re-rendered the component every time we called set state, As I mentioned, you could have complex components which are dealing with a lot of state updates on whenever user interacts with any one of the buttons or interacts with a row or whatever the data structure that we're dealing with. In those cases, the UI could become very slow and inefficient if we update on every single state update. So by batching the updates, React can avoid the unnecessary re-renders and perform updates efficiently, applying all the state changes at once in a single render pass. So it batches it, then applies the updates in one go, and then the new virtual DOM compared with the old one shows exactly what needs to be updated based on how many updates were taken. I hope we all understand this concept, and now it's easier for us to identify and fix this when the time comes. Now let's go to our final topic of the day, which is what is useEffect and understanding useEffect in detail. So before we start with understanding useEffect, we need to understand what are side effects. In React, side effect refers to anything that happens in your component outside of rendering and that impacts something external to the component. For example, data fetching, subscriptions, DOM manipulations, or if you're calling logger to log information. For someone who's coming out of JavaScript, imagine your React component is like a function. So the function's job is to take some input, whatever props we provide, and then return the result, which is your user interface. In an ideal world, this function would just focus on rendering the UI and nothing else. So you provide it up with some data and props and it renders the markup. But sometimes we need our component to do more than just display the interface. Based on user input, we might want to fetch some data from an API and show the results based on that data. We might want to set up some delays in terms of timer intervals that you can only click on this button after 5 seconds have elapsed or 10 seconds have elapsed. Or you might want to interact with some of the session storage, local storage data, parse it, and then show it to the user. Or if you just want to change the document title. So on every click, we want to show, okay, you have clicked 20 times on the page. So all of these are side effects. The side effects in React have to be managed. In React, the component needs to deal with side effects, but we need to have a way to handle them in a controlled and predictable manner. And that is where the useEffect hook comes in. So useEffect is one of the most important hooks in React. It lets us perform side effects in functional components. The function which is passed to useEffect is called after the component renders, which means it does not block the initial render of the UI and is executed only once the DOM elements have been properly painted on the screen. Now, the structure of a useEffect is it takes two parameters. First one is callback function, which has the logic of our side effect, which goes into this function. What do we want to do when the dependency array changes? Dependency array. The second one, this array is optional. This array defines the conditions that will trigger this particular effect to rerun. It contains the values, which could be either state values or the props that are passed on to the component, which, when changed, will cause the effect to execute again. Also, for someone who is coming from a class-based React components background, another reason why useEffect is needed is because the functional components, we do not have any lifecycle methods. But useEffect hook replaces these lifecycle methods, allowing us to handle side effects declaratively and in a more organized manner. Now, let's see how useEffect works. To fully understand how useEffect works, we will look into various scenarios where useEffect is applicable, how it handles the side effects, and what happens if we do not pass the dependency array. So here is the first component. As we can see, the name of the component is run on each render. So here we have a useEffect to manage the dependency, but since we have not passed a dependency array, this useEffect will trigger every time the component is re-rendered. This can be useful when side effects don't need to depend on any specific states. Like for analytics, we need to count how many times the component is rendering. In that case, this could come in really handy. Let's look at the implementation. So here, run on each render is the count. Let me refresh. Component rendered, current count is 0. 1, 2, 3, and so on. So every time the component is re-rendered, the useEffect keeps on running. Now let's look at the second example. Now this is the second example where the component name is run only once. Here we still have a count or a state variable. But in useEffect, as we can see, we have a callback and we have a dependency array which is empty. So whenever the dependency array is set as empty, the useEffect runs only once after the initial render. This is very similar to component didMount lifecycle method in class components, only for those who are coming from class components background. But yes, in this example, the component mounted will be logged only once and document title will be updated only once. So we can still update the state variables, but those state updates will not cause our useEffect to run again. And this is something that we can check right now in the running application. Let me go here, clear the log from our previous validation, and the component mounted came up. The reason it is coming up twice is because of strict mode enabled on our React application. Let me just showcase for people who are new and don't have an understanding of React strict mode. So React strict mode renders the component twice, only in development mode, to help us identify the potential issues in the code, particularly related to the side effects and state management. If you forgot to clean up something and all, it throws appropriate errors. And this is the reason why it's rendering twice. So for now, what I'll do, I'll remove the strict mode from our application, not recommended, but just to showcase. And I'll go back to our component, refresh. Okay, component mounted comes once. Now I'll increment our state variable, but we see the component mounted does not log again. The useEffect that we have seen runs only once in our application during the initial render of the component because of the empty dependency array. Now let's look at the third example or the third use case for the useEffect. All right. So this third use case is a little tricky. So please bear with me as I explain this line by line and what all changes I had to make. The third use case that we usually encounter is whenever we are fetching data from an API that updates one of the state values and we need to act appropriately. Here, the value that we are interested in is user ID. So you're in Facebook looking at the profile picture for one of your friends. Whenever you click on the next person, the user ID for the active profile changes. And that way you would have to fetch the new image and showcase to the user. It's near about mocking the same scenario where we are showing the user ID along with age of user. And the age of user is 25 plus whatever user ID we come up with. And in this, since we do not have an active API, what I have done is I have created this fake fetch user data method, which returns you a new promise. After a time elapse of 1 second, it resolves that promise with the user name as user ID and age as 25 plus whatever user ID we get. And in our useEffect, whenever user ID changes, we call this method fake fetch user data and set the user data, which is our state variable, to the new data which we just resolved. In our render method, what we are doing is if user data is available, you showcase the profile information with your name, age, and in case we are in process of fetching the data, loading user data message is displayed to the user. Now going to app.js where I'm consuming this component run after fetch. The changes that I have made is I have created a state variable called current user ID and set current user ID. The default value for this is 1. So our user ID by default is 1 when the application loads. On handle click, we increment the user ID by 1 and this user ID, the state variable, is passed as a prop to our run after fetch method. So as we can see, we are taking this prop and our useEffect depends on this particular prop. So this method, every time user ID changes, sets the user data to null and fetches the new user data. And once new user data is available, we'll showcase that on screen. This is how it is working. And on click of our button, I'm just calling the handle click method we saw here. Let's go and look at this example running on the localhost. Here is our application. Let me refresh it once again. For 1 second, you see that loading user information message. And then we see this profile information. I'll go ahead and click on this button. As we saw in our app.js, whenever I'm clicking on this button, change user ID handle click will be triggered, which will update the current user ID and trigger our useEffect because user ID has changed now. I'll go ahead and do that. Now user ID should be 2. And as we can see, the name has been updated to user 2 and age is appropriately updated to 25 plus 2, which is 27. In the next one, it will update to 3. So the use effect is managing our side effect appropriately. Whenever user ID changes, it is mocking the behavior of fetching the user data and showing the new user information after the fetch is successful. This is probably one of the most used use cases that I've seen of use effect in the applications, and it is good as a starting point. As you advance in your journey of React, you will understand custom hooks and how we can improve this even further. But this is good enough for now. Please do not worry about it. All right, let's look at the fourth and final example of our use effect hook. This is the one with cleanup. So we already know that in our use effect, we take two parameters. One is the callback function and the second is a dependency array. In this case as well, I've kept the dependency array as empty so that this use effect runs only once during the initial render cycle. The key point to notice here is any function that you return from your use effect is considered as the cleanup function, and this will be executed when your component is about to unload. So this cleanup could be anything, your timers, subscriptions, event listeners. We can return a cleanup function from our use effect, and this cleanup runs before the component is removed from the DOM and before the effect runs again due to dependency changes. So in case you had a dependency here, every time this is about to run again, it will run this function to ensure that everything is cleaned up before we set new bindings in place. There were some changes which I had to make in our app.js as well, where we are consuming this. So we have this with cleanup component imported, and I have set up a state variable show component, its appropriate setter, set show component, which is set to true by default. So when we load our page, we will be able to see with cleanup method. And on click of this button, we are setting the set show component to false and it will keep on toggling. That's why the button says toggle component. There are two logs. So whenever the use effect runs, you will see setting interval to show time in seconds. And whenever the cleanup happens, the component is about to unload or has been unloaded, you will see this clearing interval. Let's look at the running code. I'll refresh. Here we see the component renders on screen and you see the seconds changing. And we also see the log that came up when the use effect ran during the initial render. Now I'll click on toggle component. We see the component does not exist on document anymore. Let's inspect and see. We see after H3, there's no component. We see the break and we see the toggle component button. I'll click on this again. And that's why before cleanup, it ran the clearing interval, that cleanup function. Now I'll click on toggle component once again. We see the component came up. The seconds are updating again, and it would have ran the use effect once more. And the same cleanup will happen every time the component is unloading. This is really important and recommended way to clean up any events that you are binding in your components. So with this, now we understand use effect properly, and we also have a solid understanding of the basics of React. What is React? What is virtual DOM? Why is it fast? How do we think in terms of components? What is useState and what is useEffect? With this knowledge in place, you are ready to start developing your applications, and we will learn advanced concepts in time. But now you won't have any blockers when we start developing the basic to-do app that we discussed in our previous session. Appreciate everyone's time. Thank you for going through this video and hope I was able to help with your understanding. See you in the next one. Thank you.